Hello student. In this class we are going to discuss continuation of that stoichiometric related problems. The last video we discussed stoichiometric related problem, especially percentage purity problem, percentage impurity problem. Now I am going to discuss very important idea, which is the limiting reagent concept. This limiting reagent concept will be utilized over the entire chemistry. Even there are reactions will be there in thermodynamics where there is a heat of neutralizations. There we can utilize. There are inorganic reaction is there. There we can utilize. So now that's why this limiting reagent concept can be utilized in several places of chemistry whenever I need a equations, stoichiometric equations. So now this is a stoichiometric related problem. Generally, stoichiometric related problem means what is the basic idea I told you. First, you need to write down the balanced chemical equations. That is very important and essential. So यार थोड़ा सा तो इक्वेशन पहले लिखना पड़ेगा. जो इक्वेशन से वो पूछ रहा है वो इक्वेशन पहले लिखना पड़ेगा. बैलेंस करके पूरे तरीके से अच्छे तरीके से वो लिखना पड़ेगा. उसके बाद जो जो बोला वो अप्लाई उसी में अप्लाई करना है. ये चीज दिमाग में एक बार बैठा लो. whenever there is a stoichiometric related problem, पहले मुझे balanced chemical equation लिखना ही लिखना पड़ेगा. Then only I can deep into the problems. Is it clear? So now you look at, now our topic is a limiting reagent problem. Limiting reagent. Limiting reagent in short form, we used to call it as a LR, limiting reagent problem. Very important idea. So what is limiting reagent? LR. The reagent which is fully consumed in a chemical reaction. The reagent which is fully consumed in a chemical reaction. RXN means reaction. Reaction we used to write down like RXN. What is excess reagent? This limiting reagent concept need to apply whenever at least more than one reagent is present and bringing the product. Then only, in that case only, we can apply the limiting reagent concept. That is, you need to remember. So now excess reagent, the reagent which is excess, is called excess reagent. Here means this is I am writing excess reagent. Excess reagent used to write down LR, limiting reagent. And here excess reagent. The reagent which is excess is called as a excess reagent. The reagent which is a fully consumed is a limiting reagent. Now, and another point always remembered, as per limiting reagent, as per LR means limiting reagent, always product used to form. What is the meaning of these things? That means if I want to catch it up, how much amount of product form or how many in gram or how many moles of product form, then I have to look it for LR. That means limiting reagent. How much limiting reagent is consumed, proportionately that amount of product will be formed. Okay, na? So that is the meaning of as per limiting reagent, always product used to form. These 3 points is very important. Now, if I am taking a one reactions and let us understood how to find out the limiting reagent. So for that, first we are taking a one reactions like nitrogen plus 3 moles of hydrogen is reacting and forming 2 moles of ammonia gas. All are gaseous state for the gas. So they will not give you that reaction. As we are learning, that's what first I write down the balanced chemical equation. What the problem they will give you? They'll give you in a container. This is your container. 0.4 mole nitrogen mixed with 5.6 mole of hydrogen. This is they are giving. Now they are asking who is Lr, who is Er, and how much ammonia will be formed. How much ammonia will be formed? Ammonia formed. That is a question. Now we need to find out how to find out the limiting reagent. For that purpose, what we need to do? That is only I am teaching you. That means these reactions they will not give you. They'll give you like this. As we are learning, that's why first itself I write down the reactions. So now once they will give you these things, then your job is to write down the balanced chemical equation. That means you need to write down 1 mole of nitrogen which fully react with 3 moles of hydrogen is producing 2 moles of ammonia. This is you need to write down. This is called balanced chemical equations. And now once you write these things, then before the reactant or reagent, whatever the number is there, that number represent the number of moles. That is called as a stoichiometry. That means stoichiometry is a measuring. Then we came to know 1 mole of nitrogen used to react with 3 moles of hydrogen is producing 2 moles of ammonia. So now whenever they are giving like this, first what we need to do? In a problem, they are giving 0.4 mole of nitrogen mixed with 5.6 mole of hydrogen. Suppose if they are giving you in terms of a whole number, easily we can find out. That means we will see, okay, 1 mole used to react with a 3 mole. Suppose if they are giving 1 mole of nitrogen mixed with 6 mole of hydrogen, then immediately I will understood 1 mole of nitrogen only will react with the 3 moles of hydrogen. That means 3 moles of hydrogen will be extra. That means hydrogen is a excess reagent, nitrogen is fully reacting, is a limiting reagent. But here the problem is giving in terms of a fraction. That's why you need to know the method how to find out the limiting reagent. First job is to write down the balanced chemical equations. After that, what we will do? I will do for nitrogen calculations we will do. Here I am writing for nitrogen cal means calculations we will do. And here for hydrogen cal means calculations we will do. So now you look at for nitrogen what calculations we are doing. Whatever they are giving the mole divided by their stoichiometry. Whatever moles they are giving, that mole divided by stoichiometry. We have to do that one. So whatever mole they are giving into the problem for nitrogen, 0.4 by their stoichiometry. Stoichiometry means stoichiometric coefficient. By their stoichiometric coefficient. That means before the reactant what number is there? Here I am writing SC. SC is not a schedule cost. Here SC is a stoichiometric coefficient. So now before that whatever number is there, that is a stoichiometric coefficient. That represent the number of moles. With that mole they will react and that mole they will product is to form. So now here stoichiometry nothing is there means 1. So stoichiometric coefficient of nitrogen is 1. Stoichiometric coefficient of hydrogen is 3. Stoichiometric coefficient is ammonia is 2. Always you can do like this. But write down balanced chemical equation. Write down above stoichiometric coefficient you write down. Then you will get a full clear pictures. So 1 mole of nitrogen react with 3 moles of hydrogen producing 2 moles of ammonia. And then for nitrogen we are doing calculations. Whatever mole they are giving into the problem for nitrogen, that mole divided by stoichiometric coefficient. Stoichiometric coefficient for nitrogen. Stoichiometric coefficient for what? Nitrogen. That's why 0.4 by 1. This value is coming how much? This value is gives rise to 0.4. This value is coming for this. Now we are going for calculations for hydrogen by same methodology. Then you look at for hydrogens. So hydrogen, whatever the number of moles they are giving, that 5.6, okay na, divided by stoichiometric coefficient of hydrogen, which is nothing but a 3, and this is nothing but a gives rise to value. If you look at roughly 6 means it is 2 is to come, so less than 2 some value will come. So if you exactly calculations if you done, so then it will come exactly you can do like this. You can do if you wish 56 by 30, because if you take this decimal point here it will be like this, then 31 ja 30, 32 ja 60, so that's why 31 ja 30. So then immediately you will get these things 26. Then this one, now you look at 260. 260 means your 8 into 30, 240, 9 into 270, so then obviously 8. So then immediately you will get 1.8 something, it will come. So then roughly if you take, it will be nothing but a 1.8. Now if you look at over here, among these two calculations for the two reagent, if more than 2 is there, also I can do that one same way calculations. So but for limiting reagent, excess reagent, at least more than one reactant or reagent is required. So now among these calculation we observe, for nitrogen value and for hydrogen value we will compare. Among these which is coming minimum, this value is nothing but minimum. That means this is a smaller than 1.8. Which value is coming minimum? Definitely that reagent is a limiting reagent. So now this value is coming minimum, because if I compare between the magnitude of the value for hydrogen and nitrogen, for nitrogen is coming 0.4, for hydrogen is coming 1.8. That means 0.4 is smaller than 1.8. So this is a minimum value, and definitely my nitrogen is a limiting reagent. So then who is my limiting reagent? My nitrogen is Lr. By default other will be what? Excess reagent. So then who is my excess reagent? Hydrogen is my ER, excess reagent. You look at very fantastically, very easily we calculate the limiting reagent concept. That means whatever mole is there into the problem divided by stoichiometric coefficient from the balanced equation of that particular reagent, if that value, if I compare, which is giving the minimum value is nothing but a what? Limiting reagent. So we got that limiting reagent, and by default other one is, as two reagent is there, if I got one is limiting reagent, by default other one will be what? Excess reagent. So now we got limiting reagent as well as excess reagent. Then if you look at, they are asking how much. We got these two answer. Lr is, here we got Lr is nitrogen, Er is hydrogen, and then how much ammonia formed. I just told you, as per limiting reagent, product is to form. That means if you look at the stoichiometry, 1 mole of nitrogen react with a 3 moles of hydrogen is producing 2 moles of ammonia. But here how much limiting reagent? Limiting reagent is nitrogen. That means nitrogen, whatever mole is there, that will be fully consumed. That means 0.4 mole of nitrogen will react with how much? 3 times of that moles of nitrogen, 3 times of mole will be there for hydrogen. That means here if 0.4 mole of nitrogen react, here how much will react? 0.4 into 3, because the stoichiometric ratio will be 1:3, nitrogen mole is to hydrogen. That ratio they will maintain. That's why 0.4 mole nitrogen react means here how much react? 0.4 into 3. So that's why this much amount of hydrogen react, and 1 mole of nitrogen is producing 2 moles of ammonia. That means what will be the moles of nitrogen? Double amount of ammonia will be formed, and as per limiting reagent, product will be formed. Then moles of nitrogen, how much reacted? 0.4. Then ammonia is forming how much? Double amount, which is nothing but a 2 into 0.4 mole. So that means your ammonia formed, how much they are asking? Then ammonia formed will be how much? 0.8 mole. 2 into 0.4 means 0.8 mole. They can ask you how much hydrogen is extra. Initially it was there 5.6 mole. Reacted how much? 1.2 only reacted. 0.4 into 3 means 1.2. Then ER amount. ER means hydrogen. ER amount will be how much? Total giving 5.6. Reacted is how much? 1.2. That's why 5.6 minus 1.2. That is your ER amount. Excess. वो पढ़ा रहेंगे. Yes or no? Clear or not? So now we understood how to designate which is a limiting reagent when more than one reagent is there, and it's a very important concept. You need to write down the balanced chemical equation. In the problem, whatever the moles they are giving, suppose if they are giving in terms of a mass, you can calculate in terms of a mole. You know how to calculate the mole, because whatever, if they giving mass, given weight by molar mass. In case of an atom, atomic weight. In case of a molecule, molar mass means molecular weight in gram. Yes or no? In case of iron, formula unit mass is a molar mass. You know all those points already we discussed. So if I give you another problem in terms of a mass, do you able to solve? Yes? Okay. Let us look at in terms of a mass limiting reagent problem. Okay na? Okay. Suppose I am giving you 48 gram of magnesium mixed with 96 gram of oxygen gas. Then who is a LR? Who is a ER? That is the questions they ask over here. Then in terms of a mass they are giving, then they are asking the problem who is a LR and who is a ER. For that purpose also we need to first write down the balanced chemical equation. Yes or no? That means magnesium when will react with oxygen, little bit heat is definitely required, then it will form a what? Magnesium oxide. If you write down that equations, magnesium react with a oxygen, it is forming a magnesium oxide. So that means if you balance these things, so then here I am giving 2 Mg and here I am giving 2 MgO. Now if you look at this reaction is a balanced reaction. Yes or no? Because in reactant side 2 magnesium, 2 moles, product side 2 moles of magnesium. Reactant side 2 moles of oxygen atom, product side also 2 moles of oxygen atom. So everything is balanced in this reaction. Now, whenever you write down the balanced chemical equation, you got the stoichiometric coefficient. What is stoichiometric coefficient? 2, 1, 2. Yes or no? I told you, always write down the stoichiometric coefficient. 1, that means you get the mole ratio. That means 2 moles of magnesium will be reacted with 1 mole of oxygen gas is forming 2 moles of magnesium oxide. And now that is called stoichiometry. That's why stoichiometry is a measuring. So now if you look at over here, then once you get the mole ratio, I told you by default you will get a mass ratio, because mole into particular substance, molar mass, if you multiply, you will get amount of substance. YMAP we discussed as simple as that. From the moles, if I want to reach to the amount of substance multiplied by molar mass, that only if you do. Magnesium means molar mass of magnesium is nothing but atomic weight. Atomic weight is nothing but how much? 24 grams. Magnesium is 12 atomic number. I told you if you make it double, it will be that molar mass. Not all cases, but it will reach near to that values. So now immediately you know here how much is reacted, because 2 mole is there. That's why how much amount is reacted? 2 into 24, which is nothing but a 48 gram. And then oxygen atom is 16. That's why 2 is there. 2 into 16, which is nothing but a 32 gram. And now here we are getting, if you look at 2 moles of magnesium oxide. Magnesium is 24, oxygen is 16. So that's why 24 plus 16 is nothing but a 40 into 2. So that's why 2 into 40, which is nothing but a 80 gram. Even that Lavoisier law is there. So in my class already that will be explained thing is there. If you have like that, the summation of mass of the reactant will be equals to summation of mass of the product. In that Lavoisier law is there. There we discussed laws of combinations is there. There we discussed this concept. Summation of mass of the reactant will be equals to summation of mass of the product. Except nuclear reactions, there is a huge energy will be change up there. Because of that, there will be some mass will be destroyed. As per the Einstein equation, E equals to mc square. So now, but here small reaction, there chemical reaction, nothing going to change this much of huge energy. Small energy change is there. That's why there will be no effect on the mass. Is it clear or not? So now that's why if you look at here we get the clear picture that 48 gram of magnesium will be reacted with a 32 gram of oxygen. But here they are telling 48 gram mixed with a 96 gram of oxygen. 48 gram only will react with 32 gram. So that's why who is a excess? So then immediately in my method also you can easily do it. By itself I am understanding 48 will react with only 32 gram. That means by default I am understanding my limiting reagent is a magnesium. My excess reagent means extra will be there, which reagent, which is nothing but oxygen. If you want to do my method, that way also you can do. Here they are giving very whole number. If I write down the balanced chemical equation, I can catch it up. But if they are giving in a fraction, then what you will do? Then my method only will help you. So here if you look at, you can easily find out number of moles of magnesium, because mass to number of moles divided by molar mass. Y map always remember. So they are giving 48 divided by molar mass means how much? 24, which is nothing but a 2 mole. Then number of moles of oxygen. Number of moles of oxygen will be equals to given weight by molar mass of oxygen, which is 32, which is gives rise to nothing but a 3 mole. And now you look at, I told you that whenever the number of mole, that means 2 mole of magnesium mixing with 3 mole of oxygen. Then I told you for calculation for oxygen cal and for magnesium cal we will do. Then oxygen number of moles is there how much? 3. By their stoichiometric coefficient. Stoichiometric coefficient in a balanced reaction is what? 1. So 3 by 1 equals to 3. Now for magnesium, number of moles is giving 2 by their stoichiometric coefficient, which is 2. 2 by 2, which is giving rise to 1. Among 3 and 1, which is a minimum value? 1. So that's which is a minimum value, that is a LR. So that's why magnesium is a LR. Already you look at, we got it the LR. So that's why my method never going to give you any wrong answer any point of time. Is it clear? So we understood limiting reagent concept in terms of a mole and in terms of a mass also. If they are giving, you can easily solve the problem by balancing the by write down balanced chemical equations. You can easily get it. Now next, another important stoichiometric related problem we will discuss, which is nothing but a percentage composition problem. Let us look at how to find out the percentage compositions. Okay, na? Okay. So for percentage composition, it is another stoichiometric related problem. This is another stoichiometric related problem. In the stoichiometric related problem, subcategory is there, percentage composition problem. Percentage composition problem. Some people, first of all, this chapter based on the calculation and understanding of basic idea. Suppose some student are thinking, sir, how I will came to know the reaction? You need not to worry. Whatever reaction we are utilizing, it will be there in your inorganic portions. Whenever inorganic portions will come, you will revise that one, and you will also very comfortable to write down that reaction like that I am writing. So that means S block element is there, P block element is there, D block element is there. There you will even salt analysis is there. That means qualitative analysis, inorganic, very important for JE, for NEET, as well as for JE Advanced, very important, practical chemistry. So qualitative analysis, discussions will be there in this channel, every corner. Even paper discussions will be there, question answer discussions will be there. You just keep watching and subscribing, sharing and following. You please, if you do these things and if you come to my channel, you will get entire chemistry world and you will be confident always, and which will help you to crack your competitive exam, your board exam, and you will be go with the exam hall with a full of confidence. So now you look at stoichiometric related problem. In that stoichiometric related problem, first we will discuss percentage composition problem. It's very important. Two problems we will discuss one by one. We will understood. We will be master over this concept. Suppose if you look at, they are giving the problem 2 gram of mixture of sodium bicarbonate plus sodium carbonate on heating produces 0.01 mole of carbon dioxide. Then they are asking percentage compositions of sodium bicarbonate into the mixture as well as they are asking percentage composition of sodium carbonate into the mixture. That is they are asking, and this is your problem. And in this problem what they are asking, 2 gram of mixture of sodium bicarbonate and sodium carbonate is there, and in that mixture is itself is a 2 gram. In that I don't know how much sodium bicarbonate, how much sodium carbonate. If I came to know, then my problem is done. Then I will know that value divided by 2 into 100 is a percentage of that substance. But I don't know out of 2 gram of mixture how much amount of sodium bicarbonate and how much amount of sodium carbonate is there. For that purpose only they are giving you additional data. Here you need to know 2 points. Sodium carbonate is a stable carbonate. On heating it will not dissociate into the corresponding substance. They are thermally stable. In S-block element we will study these things, because down the group, especially except lithium carbonate, because lithium has a diagonal relationship with a magnesium, like a magnesium carbonate will be dissociated into magnesium oxide and carbon dioxide. Likewise lithium carbonate also will be dissociated into lithium oxide plus carbon dioxide. But except lithium, all other alkali metal, sodium, potassium, rubidium, their carbonate, cesium, their carbonate are highly stable due to high lattice energy. Their cationic size and anionic size are very compatible, so that's why lattice energy is very high compared to their corresponding oxide. In chemical bonding chapter we will study lattice energy. Lattice energy is directly proportional to charge, inversely proportional to size. We will discuss that things over there also. So even S block it is there. These are thermally stable carbonate. Only these informations you need to know, that sodium carbonate is thermally stable carbonate. It will not give rise to corresponding metal oxide plus carbon dioxide. So that means whatever carbon, once we came to know that information, immediately I able to catch whatever carbon dioxide is coming, that is coming from sodium bicarbonate. Sodium bicarbonate is unstable. So this sodium bicarbonate used to dissociate like this. As per this equation, in Solvay process is there, there these discussions also is there. You need not worry in a single inch. All things will be covered up. These 2 moles of sodium bicarbonate will be dissociate as per this equation. And you look at 2 unit of sodium, 1 unit of carbonate gun. Then who is there? 2 unit of hydrogen and 1 unit of carbonate. Means H2CO3. H2CO3 means always we will write down H2O plus CO2. They are little unstable, easily dissociate into H2O plus CO2. So that's why on dissociation you look at everything balanced. 2 sodium, 2 sodium, 2 carbon, 2 carbon, 2 hydrogen, 2 hydrogen, 6 oxygen atom, 3 plus 1, 4 plus 2, 6. Everything is balanced. So that means once you write down, because percentage composition problem itself is a stoichiometric related problem, your first and foremost job, समझा करो यार, first and foremost job is to write down the balanced chemical equations. Okay ना? आपको पहले balanced a chemical equation लिखना चाहिए. Then only you can proceed with the problems. So that's why जब आप balanced chemical equation लिख लिया, वहीं से आपको पता लग गया कितना मोल ऑफ प्रोडक्ट, कितना मोल ऑफ रिएक्टेंट से आ जाएगा आराम से. We will catch it up like that way. So then immediately you look at how many moles of CO2 is coming? 0.01 mole. So generally 1 mole of CO2 used to come from 2 moles of sodium bicarbonate. Here is coming out how much? 0.01 mole. So obviously 0.01 mole will come from double amount of this. That means 0.02 mole of sodium bicarbonate will give 0.01 mole of carbon dioxide. Then mole to the mass, if you want to convert, multiplied by molar mass. Sodium carbonate molar mass means sodium is 23, hydrogen is 1, 23 plus 1, 24, and carbonate means 3 oxygen, 3 into 16, 48 plus carbon 12, 60, 60 plus 24, 84. Molar mass of sodium carbonate is 84 gram. So that's why amount is how much? Amount of sodium bicarbonate will be equals to, which is giving 0.01 mole of carbon dioxide, which is nothing but this mole into molar mass. Molar mass is how much? 84. So which is nothing but if you look at 1.68 gram. That means we came to know whoever carbon dioxide is giving, it is coming from sodium bicarbonate only, because sodium carbonate is a thermally stable carbonate. Now total mixture was there 2 gram, and then from the moles of CO2, by writing the balanced chemical equation, I catch it up moles of sodium bicarbonate. From there I catch it up amount of sodium bicarbonate in a mixture. How much amount? Out of 2 gram sodium bicarbonate was there 1.68 gram. So then sodium carbonate will be there how much? Sodium carbonate 2 minus 1.68, which is nothing but a 0.32 gram. Then percentage purity, percentage composition they are asking. Then percentage of sodium bicarbonate. Percentage of sodium bicarbonate will be equals to amount of the sodium bicarbonate in the mixture, which is 1.68, with respect to total amount of the mixture, which is 2 into 100. This is your calculation. I think simplification you can do by yourself, no issue. Then percentage of sodium carbonate, you can do 100 minus percentage of sodium bicarbonate, or that amount you can put how much sodium bicarbonate, 0.32 out of how much, 2 into 100. You will get the percentage of sodium carbonate over here. Yes or no? Clear or not? Very simple idea. So that's why the two information for this problem is important. One is to know that sodium carbonate is a stable carbonate. Whatever carbon dioxide is coming, it is coming purely from sodium bicarbonate dissociation as per the stoichiometric. From there we catch the moles of bicarbonate, converting to the amount of sodium bicarbonate, multiplying with a molar mass of sodium bicarbonate. Then from the 2 gram mixture, how much sodium bicarbonate, we got the clarity. Then I convert percentage, whatever amount of sodium bicarbonate with respect to the total, into 100. Then we got the pictures. Is it clear or not? Okay, let us do another problem based on percentage compositions. Next problem, what they are giving, like this: 10 mole of acid mixture. In this acid mixture, who is there? In this acid mixture is there HCl plus H2SO4. So 10 mole of acid mixture, who is there? HCl plus H2SO4, required 18 mole of NaOH for complete neutralization. For complete neutralization reactions. Neutralization reaction means acid and base will fully reacted and they will form a salt and water. That is called neutralization reaction. For complete neutralization reactions, then they are asking percentage of HCl in mixture is how much. Then they are asking percentage of H2SO4 in mixture, how much. That is the 2 point they are asking into the problem. in the 10 mole of mixture of acid is there, but out of that I don't know how much HCl and how much H2SO4. That's why this problem generated. If I came to know out of 10 mole of acid mixture how many moles of HCl and how many moles of H2SO4, problem is not generated, because easily that the moles of HCl with respect to 10 into 100 if I did, then I will get percentage. But I don't know exactly out of 10 mole how much HCl and how much H2SO4. That's why this problem is created. Now you look at how I will explain these things. I told you, you need to know, write down the balanced chemical equation. Both the acid is reacting with what? NaOH. And total NaOH, how much consumption is there? That data they provided. Then for that purpose, first you write down the balanced chemical equation. Like HCl react with a NaOH, it is used to form NaCl and water. Now you look at this is a balanced. So 1 mole of HCl will react with a 1 mole of NaOH is forming 1 mole of NaCl and 1 mole of water. That is forming. Reactions always will be taking place as per stoichiometry. Here stoichiometric coefficient, I told you, write down here stoichiometric coefficient 1, 1, 1. Yes or no? So then 1 mole of HCl is to react with a 1 mole of NaOH is forming 1 mole of NaCl and 1 mole of water. So then out of 10 mole, I don't know how much HCl. In algebra, what we don't know used to take let x, let y, let z, whatever. I am taking same out of 10 mole acid mixture, 10 mole acid mixture, HCl present x mole. So then by default H2SO4 will be equals to 10 minus x mole. Yes or no? Because both the, if you added up, it will come to the both the acid mole. If you added up, it should come 10. So that's why if x mole of HCl is there, then H2SO4 will be 10 minus x. As simple as that. Now 1 mole of HCl required 1 mole of NaOH. Then immediately I can write down x mole of HCl will require x mole of NaOH. Reaction will always occur as per stoichiometry. 1 mole of HCl will react with a 1 mole of NaOH. X mole will react with x mole of NaOH. Then for H2SO4 beta, write down the equation. H2SO4 plus NaOH. H2SO4 is a dibasic acid. Basicity is 2. We will study in equivalent concept. You need not to worry, my dear student. So that's why H2SO4, 1 mole of H2SO4 react with a 2 mole of NaOH is forming Na2SO4 plus 2 moles of water. That means 1 mole of H2SO4 used to react with a double amount of NaOH, means 2 moles of NaOH, because stoichiometric coefficient, if shortly write down over here 1, 2, 1, 2. We will get these things. Then immediately if you look at, we have in acid mixture how much H2SO4? 10 minus x mole. So then 10 minus x mole will react double amount of NaOH. That means 2 into 10 minus x of NaOH. Yes or no? Now you look at, and here same 10 minus x. Here it will be 2 into 10 minus x. Now you look at total NaOH consumption value, they are giving 18 mole. For that, here also we get total NaOH, how much consumption for HCl, x mole, and for H2SO4, 2 into 10 minus x mole. Then if I add x plus 2 into 10 minus x, which will be equals to total mole of NaOH, which is 18. And then you look at x plus 20 minus 2x equals to 18. So then if I take this thing this side, that means minus x. So then immediately we got it. If you look at minus x plus 20 equals to 18, then x will be equals to 20 minus 18, which is nothing but a 2. So then if you look at over here itself, out of 10 moles, how much amount of value of these things is coming, if you look at very clearly. So out of these things, it is coming is nothing but a 2 moles is coming. 2 moles of x value is coming 2 moles. How we are getting? The total consumption of NaOH, which is x mole for with reacting with HCl, and 2 into 10 minus is reacting with a NaOH. From there we got this data over here. Because here if you look at, this is a basicity is 2, here acidity of the base is 1. So that's why if you look at these things, we will balance reactions we are getting over here is nothing but this balance reaction. For 1 mole of H2SO4 react with a 2 moles of NaOH. And that's why 10 minus x is nothing but a 2 into 10 minus x. And then total NaOH consumption x plus 2 into 10 minus x, which will be equals to 18. And from there we are getting the value of x plus 2 multiplied means plus 20 minus 2x. So which is nothing but a minus x plus 20, then x will be equals to 20 minus 18, and then immediately x equals to 2. So then that means in out of 10 moles of acid mixture, 2 moles of HCl and 8 mole of H2SO4 is there. So that's why if you look at, immediately you will understood. So that means percentage of HCl, because x value is 2, that means HCl is there how much? 2 mole. Then 2 with respect to how much? Total mixture 10 into 100. The amount of mole of the particular acid with respect to the total into 100, which is nothing but a 20%. Same way, if you calculate percentage of H2SO4, percentage of H2SO4 100 minus, you can do percentage of HCl, or you can calculate over here. So how much? 10 minus x, 10 minus 2 means 8. Then 8 with respect to total 10 into 100, which is nothing but a 80%. This is your calculation. Yes or no? So that means H2SO4 is a 80%, HCl is a 20%. That is also matching. You look at your these things, 2 mole will react with a 2 mole. So x value is 2. Then 2 into 18, 10 minus 2 means 8. 2 into 8 means 16. 16 plus 2 is nothing but a 18 mole of NaOH consumption. Is it clear, everybody? So these are the percentage compositions related problem we discuss. Limiting reagent problem we discuss. Percentage purity impurity we discussed. And the next class we will going to start concentration term, and which is very important. I hope it's clear to everyone. So please look watching the channel one by one. All video of chemistry will come, which will help you for your upcoming exam, and which will enrich you with a concept, which will open up different avenue to solve the problem for your JEE, for NEET, for advance, and all those things. Thank you everyone. Thank you all.